Hi everyone, thank you Peter for the introduction, and I will still be talking about OPM today. I'm Yulia, working with team of OPMs, and I'm a new member of OPM development team, and I will be introducing today an exciting new SPM-python package, and I will be talking it in the context of MG and EEG research. But first of all, I want to congratulate SPM with the 30th anniversary. We already heard how big of an impact SPM had on advancing the neuroimaging and our understanding of the brain. So happy birthday for SPM team and the collaborators. And I wish you many, many more prosperous years of the sound research and groundbreaking ideas. So yeah, now to science. So actually, to illustrate my words, I will show you a bit SPM in action according to Scopus. So when you try to do the advanced search on SPM as MRI, you get something like 20,000 papers. And in the recent years, it gets up to like 1,500 papers a year, which is amazing. Then you can add something like 6,000 publications for EEG research and 3,000 publications for MG research, all done with SPM software. However, I think in recent year, there is more and more MG sites, especially with the OPM development, and the new player on the, well, the new 10 years on the software toolkit field is MG-python, so the Python package for EEG and MG research. It already has 5,000 citations, so people more and more use the Python. Yes, so I decided to do it like a small survey among my peers to see what they would prefer to use if they would have had already the head of their labs. And the answer to this from my 9 devoted friends, you can't do well. Yes, so you can't do too much statistics and read too much into this data, but most of my friends who are using MG would like to use MG-python as their main software. Some people devoted for SPM, and I think they are the ones who are from the field. And some people who are using EEG would like to use EEG Lab and Field Trip. So, and I think the interesting point is the reason why. And I think the reason why is first a bit boring is that SPM is a free software, so it's more open science. But the other reasons were transparent documentation of MG-python, very diverse tutorials. So you have millions of examples of any weird pipeline you want to do. And it's a bit more flexible than SPM, so it's easier to divert from the tutorials to do your own small things. And don't get me wrong, you can do all this thing in Python or in SPM. It just, I think the threshold to get to these like small changes is a bit higher for SPM than in Python. But none of these reasons were about the algorithms. And I think SPM can offer a huge expertise for MG and EEG research. For example, we all know the DCMs, and SPM pioneered approaches for Bayesian estimation of mechanistic models in DCM, and the whole like ecosystem for DCMs is really, really well developed in SPM. The other example is, of course, OPM, which I can talk loads about. So Phil laboratory here is pioneered in the immersive reality experiments with OPMs, in the spinal cord imaging with OPMs, and in all kinds of movements with on-scalp imaging technology. And to do all of this, the team developed a lot of tools for analyzing the very noisy OPM data. So all these tools, most of these tools, are done in SPM and available sometimes only in SPM. So Tim Tierney will later talk about a bit more into details, but something like homogeneous field correction, for example, is getting to be gold standard now in SPM or in OPM analysis. Also, I think, because it's a great tool, it's also available in MG-python now. Yes. So any other expertise that SPM can offer, there's many, many more. For example, laminar MG that will be presented a bit later by Jimmy, and something like random field theory that very useful for really complicated OPM design, MG design experiments that breaks the exchangeability criteria. So yeah, I think there is a great opportunity to open SPM expertise and capabilities to a wider MG and EEG community if SPM would be available in Python. So we started working on this project a year ago, which well, I would say Johan started working on it a year ago. And now we have SPM-python that is available on the SPM GitHub, which allows you to use all the SPM functionality in the Python. And if you want to talk about it in a bit more technical details, please come to Johan poster number 1. I will tell you in a nutshell how it works. So MATLAB has a compiler that can generate a Python package around any project that's written in MATLAB. So you first generate this SPM Python package from MATLAB compiler, but it's really hard to interact with. So what Johan and Neil done later is created a wrapper around this designed package that makes it very user-friendly to interact. So now the SPM Python is something like just a normal Python package that is easy to interact with. And important points that SPM is not a replication of SPM Python is not a replication of SPM. It's not different from SPM. So if you know how to use SPM, you know how to use SPM Python. And the other thing is it's actually running in MATLAB. So even if you like plot something through SPM Python, you would see the MATLAB plotting window pop up. So it is the same MATLAB by Python. And I think on this level, it's a package that is available in Python, but it's a bit closed system. So it's like you're coding in Python to code in MATLAB. So what's the big direction in SPM Python, what we already started working on is SPM to M&E interoperability, where you can jiggle data between SPM and M&E to use both softwares. So we now have some functionality to move data between SPM structures and M&E structures. And I think it's a big and important direction to take to make it as flexible as possible. So you're seamlessly doing some analysis in M&Es and taking some functionality from SPM, then coming back to M&E for like visualization. Well, that's, so I will show you, I will stop talking, well, I'll continue talking, but I'll show you as the example we have in our GitHub. It's a very standard pipeline for just auditory work field, but it's actually a use case that I needed for my research, where I wanted to run my pipeline in M&E because in Birmingham I can only do it in M&E in the big cluster, couldn't use SPM, but I needed the specific SPM function developed here in the field. So let's try to run it. Okay. That's yes. So again, it's a Jupyter notebook available in GitHub, so you can run it. It's the data is there. So first, you install M&E. You install M&E Python. It is successful because I recorded it and checked. Yes, you import all the data you need, and here you can see I'm taking the data that M&E has in a data set provided by UCL OPM. So it's auditory field from OPM. Here I show you that you load the data. Sorry, I had to cut it. And you have all the information about channels and stuff. You do some normal standard visualization. Here you see very noisy OPM data, which is normal, 400 nanotesla plus minus, very bad power spectrum. And then you do quite a standard pre-processing notch filter that is run in M&E. Then you do some red channel annotation, not to confuse your more elaborate filters. And then what I needed is IM filters that Tim developed, probably we'll talk more about later, that is only available in SPM. So what I do here is I use a function M&E raw to SPM to transfer my bit preprocessed data from M&E structure to SPM structure. and you can see it's created the SPM EEG object. Yeah, and then I use the function I needed. I use SPM OPM function to filter my data. And then this bit has to be a bit optimized. I'm kind of moving, well, I'm moving the data back from SPM to MNE. This function runs a bit slow for a minute and a half. So I will optimize it later. So what it does, it moves the function, but it's also, because the spatial filter was applied, it saves all the projections that was applied for the data for future source localization. So the forward model will be correct after using this data. So you wouldn't be able to cancel all the projection you already implemented. Yeah, so this is a user case that I really needed for my research. Well, it wasn't for object or evoked data, but I basically needed this IM filter, which is only now available in SPM. Yes, and it works really nice. So I managed to use it in a cluster in a very different university. It's very happy. And you can see it's created the MNE structure back. And it saved all the information. You have all the channels you had before. Well, believe me, you have all the bad channels that I annotated, and all the stimulus channel was saved. So here now, and I'm showing you there is a projection applied from the IM function. And here I'm just showing that I can now use the plotting visualization function from MNE with a better yeah, so I got rid of all the interference that I wanted to get rid of, and now I'm doing the standard epoching in MNE. Well, now it's boring bit, and here you can see I did my evoked field. It looks nice. I can plot my radial sensors, so you see one dipole here, which you're supposed to see, and I can put tangential sensors, so you see a bit other topology, and that's it. So it's a very nice example of interoperability of MNE and SPM-python. Thank you very much for listening. Please, if you have any ideas how you would like to use SPM-python, write it down on the boards. I would like to thank you, the SPM team and the SPM-python team. Yeah, and congratulations again, the 30th anniversary. Thank you.